Today's class, we are seeing relation between critical constants and Vanderwaal constants. In previous classes, we have derived that Vanderwaal's equation of state by making two corrections in the ideal gas equation. One is pressure correction, one is volume correction. And we got the equation for 1 mole as P plus A by V square into V minus B is equal to RT. That is Vanderwaal gas equation. If we expand it, multiply P to V, PV, isn't it? Then PB, A by V square into V is A by V, AB by V square is equal to RT. This is the equation. Now what we do, we are making it a uniform equation and we are multiplying with V square because the LCM is V square. PV cube plus AV minus PBV square minus AB is equal to RTV square. See here. First, we have taken Vanderwaal gas equation for 1 mole of a gas where N becomes 1. It became P plus A by V square into V minus B is equal to RT. Multiply the brackets and multiply the whole equation by V square and we got PV cube plus AV plus PVV square minus AB is equal to RT square. Now what we are doing is we are making it as a uniform equation. We are bringing the V values in decreasing order, V powers. PV cube minus PBV square, we bring that RTV square here minus RTV square plus AV minus AB is equal to 0. If we rearrange this, PV cube minus V square, PB plus RT plus AV minus AB. See here, the powers are decreasing. Divide the equation by P. P we are dividing, that becomes, see here, we are dividing with P. It becomes V cube minus V square into B plus RT by P plus AV by P minus AB by P is equal to 0. That is first equation. It's very important. Here only you have to understand this thing. We have taken Vanderwaal gas equation. We have taken Vanderwaal's equation and we have multiplied this P plus A by V square into V minus B is equal to RT. We have multiplied. And what we are doing now is we are just multiplying the whole terms by V square so that we want to make a uniform equation. We multiplied it and we are arranging it in the decreasing order of powers of V square, V, and divide the equation by P so that we can make the coefficient of V cube as 1. So it became V cube minus V square into B plus RT by P plus AV by P minus AB by P is equal to 0. So try to practice this. This is only the important part. It is a third degree equation in V. It may have three real roots. Is it not? So if we go for law of corresponding states, TC, the volume, three values of V. At critical point, the gas converts into liquid. Hence, volume becomes Vc. V minus Vc is equal to 0. Volume of the gas is called Vc. That means critical volume. So V minus Vc whole cube is equal to 0. So we expand it equation this by A plus B. Isn't it? We expand this equation. V cube minus, what we are doing is we are taking this V minus Vc whole cube, A minus B whole cube formula. A cube minus B cube minus 3AB into A minus B. So it becomes V cube minus 3V square Vc plus 3V Vc square minus Vc cube is equal to 0. What we have seen the first equation, that is Vanderwaal's equation after expanding. This is the Vanderwaal's equation, V cube minus V square. This is similar to that equation. And we are equating coefficients now. 3Vc, here V cube is common. Here 3Vc is equal to B plus RTC by PC. Why we are writing TC? At temperature is TC, pressure is PC, critical pressure. And here 3V square V, volume coefficient of V is 3Vc square. What was the coefficient here? A by PC. And what is constant term? Vc cube is equal to AV by PC. This is by comparing equation 1 and equation 2, and this is an important part. Now, B and C is there. We divide C by B. Vc cube divided by 3Vc square is equal to AB by PC into, this is reversed to PC by A cancel PC, PC cancel, Vc square cancel, Vc remains. Vc by 3 is equal to B, or Vc is equal to 3B. We got one relation between critical volume and Vanderwaal constant B. Let us substitute the value in equation B. Here B, 3 into Vc is B, B square. Is it 3B square is equal to A by PC. 27 Vc is B square is equal to A by PC. Or PC is equal to A by 27 B square. This is the value of PC we got. Similarly, we substitute Vc PC in equation 1. 3Vc is equal to B plus A by RTC. A by RTC, this is there. So when we are substituting 9B is equal to B plus RTC, RTC into 27B square by A, this becomes reversed. So here 9B minus B is 8B is equal to RTC, 27B square by A, or 8AB is equal to, multiply A with this, RTC into 27B square, or TC is equal to 8A by 27B square. That is the critical temperature. So we must know the values of VC, PC, and this, that is TC. So how did we get all these things? If we want to summarize, this is the Vanderwaal's equation. For 1 mole, it is P plus A by V square into V minus B is equal to RT. We are multiplying this and arranging, making them as the powers of V, because the LCM is V square. We are multiplying with V square. So PV cube, and we are arranging this equation. Dividing by P, we get an equation where the coefficient of V is 1. P cube minus V square, P plus RT by P in plus AV by P minus AB by P is equal to, you see, the powers are in decreasing order. Next, what we know, critical phenomena, volume is equal to VC. So V minus VC is equal to 0, cubing both sides, because we get the equation where the power of V is 3. Hence we also make this. So A minus V whole cube formula we are applying here, we are get the equation 2. We compare the equation 1 and 2, where the coefficient of first VC is 1, hence VC is equal to B plus, here you see the second one, B plus RTC by PC. B is equal to this, C is equal to, we are dividing B, C and B, and we get the value of VC. You substitute VC in equation B, you get the value of PC, and similarly you get the value of TC here, 8A by 27 RB. These are the values of critical constants, or relation between critical constants and Vanderwaal constant. Units of, if you see the units of A, atmosphere liter square per mole square, B, TC, PC and AC. So this is all about this. In the next class, we will be seeing law of corresponding value, which is also an important. So today we have learned, in previous class, we had learned the critical constant and Andrews phenomena. And now the relation between Vanderwaal constants and critical constants. This is also a very, very important one. So till then, thank you for listening, and do practice and see how you are doing this thing. It's very important. What is the question 1 today? What is critical phenomena? Draw Andrews isotherm of carbon dioxide. First question. Second question, derive a relationship between critical constants and Vanderwaal constants. Thank you.